Gentles and ladymen, I'm Spiro, and I'm not a wizard. Today we're going to start a new series, because I know you can't get enough of new random series. Let me have some coffee first. And just quickly, I've canned Twitter, and I've been using Mastodon, and I found that there is now a massive retro computing community on there, and more people are joining in daily. It's awesome. I'll leave a comment down, a link down below to how you can get on. It's a federated social network, so people are able to. You don't just have to use one server or one service. There are, you can spin up your own if you want. The software is completely free. So they all interoperate, and in fact, it's not just Twitter-like social media, but there's also there are other services like one called PeerTube, which is a YouTube but decentralized, and there's a piece of software called Pixel Fed, which is the Fed is for federated, and that is basically an Instagram clone. And these are all free software. They're all interlinkable. So you get an account on one, or with one type of software, and you can follow anyone else on all these other different platforms. It's pretty cool. It does take a little bit more work, but I've had more engagement in the last few days on a smaller platform than on the massive Twitter platform. So, sidetrack. But on there, I asked if people were interested in doing me doing a series of videos about some of the old basic type-in program books. Most of them are, aimed at kids, getting them into programming. But I thought it would be a bit of a laugh to start going through some of these. And not too long ago, all these books are effectively free to download anyway. But not too long ago, Usborne Books have officially released some of their programming books, their old 8-bit programming books, for free. And I went and downloaded all of them. I think there might have been about a dozen of these books. And they make the programs work on, so we've got C64, VIC-20, Apple TRS-80, Electron, BBC, Spectrum, ZX81. Some of the older ones are... Was that a cat? My cat's been gone, probably napping somewhere for the last few hours. She missed lunch. I'm just going to pause this. Sorry about that. She'll probably interrupt now. She's having her lunchtime treat. So, Usborne Books, they released a whole lot of these for their 8-bit platforms. And you can see they look graphical. I was like, that's exciting. The first one to kind of be graphical is this one here, which is called ICEBERG, which we'll start with today. But to give you a rundown, this book published in 1982. There's a whole lot of little games here, and these are all mostly about either random number generators or like hit the key really fast or fast enough. Things like the shootout is like a cowboy shootout, and they they'll do things like inject little random pauses to give you a chance to hit a key, and if you don't get it, you lose. And they're kind of, most of them are effectively the same thing, with different themes. You press a button quickly to kill the robot invaders, or quickly to shoot the other cowboys, or a couple of them are like desert tank battle, and I think the battle at Traitor's Castle are the same kind of thing, where you've got like this trajectory, like the desert tank battle is like I think like it's called Tanks, an old game, where you're one tank on each side of the screen, and you've got to kind of aim and say, okay, I'm gonna shoot on this angle, so you set like the angle and the velocity or something, and then sometimes you overshoot, sometimes you undershoot, and they're the same kind of thing. One is with tanks and one is with shooting bows at a castle. But the first cool one I think is ICEBERG, and so I think we're going to start with that. This is kind of cool. It tells you a little bit about programming. They make the assumption that that you're probably young, and B, that you haven't done any programming before. So they kind of start from scratch. So here we go. This is the robot missile. You got 4 chances to defuse a missile. Basically prints up a random code, and you've got to try and type the correct code, blah blah blah. You've got to guess a letter in this one. So it generates a random character, and you've got to go through the alphabet and try and pick, and you've only got 4 guesses. Let's scroll down a wee bit. Blah blah blah. Here we go. ICEBERG. So this is the one. Your hull is badly damaged. You have no weapons to speak of. As you limp slowly home through treacherous iceberg-strewn waters, you become aware that an enemy ship is tailing you. Strangely, it can detect you, but not the icebergs. So your best chance is to lure it into hitting one. Your computer will print a grid showing the position of your ship, Y. So again, it's character graphics. So your ship is represented by a Y, the character Y. The enemy, Z, and the icebergs are represented by asterisks. You can move one space north, south, east, or west each go. The enemy moves towards you by the most direct route. It can move diagonally too. If you move in any of the 8 positions surrounding the enemy, you will be captured. If you hit an iceberg, you will sink. Can you escape? So it's fairly basic. It's no pun intended. Now, these books have got a bunch of symbols, so they're designed that in general they will work for all platforms, but some platforms have got a few little differences. So in our case, we're using the C64, so that is represented by the triangle. And this is the random numbers work a little bit differently. So they will give at the bottom the differences for your computer. So, if you're using the where did we see that? I don't know if it's I think it must have been way earlier on that it told me where or maybe at the end, where it tells you what computer is symbolized by which. Okay, so there's at the end it looks like it's got a summary of the basic commands, which is kind of cool. Oh yeah, there we go. It's a bit of a how to write your own programs. Where do we find the... No. It's in there somewhere. Maybe it was in previous listings where they said anyway, take my word for it. The I can't remember what the other symbols are, but I know that the triangle is the C64. So when we hit a line that's got a triangle, we need to look down the bottom. So it's got the above listing will work on a ZX81. So this has been written. You can type that in as is on a ZX81, and if you use one of the other computers, you've got to make the changes down below. So on the Commodores, lines 30, 50, 70, 80, 110, 120, we change the RND to RND bracket 1. We'll get to that. So let's start on it. Now I've got this here. I'm not sure how visible this is going to be because I thought I'd play with this. I found online a bunch of basic tools that were published in a disc magazine called Lodestar, and it's kind of hard to read that line, but it's kind of cool because it highlights the line the cursor's on, which is awesome. But it also, if you enter in some code when you list it, see it changes the line numbers to be in white and the code to be normal. Now if we change our color here and go 20 print high again, right, we can keep coding like that, but as soon as we go list, it changes our prompt back. So I'll try and remember I'll switch it to white, so it should at least be a little bit more legible for you. Just know, you've probably noticed by now, but if you're viewing this on a mobile device, you're probably going to struggle anyway because I've got the PDF loaded here as well. So sorry about that. How much we're in? 12 minutes, and I'm only just starting. You're used to me rambling now anyway. Okay, so let's type this in. Now I'm going to make a couple of little changes to it just on the ICEBERG. Alright, print ICEBERG. Great. Now we dimension an array here, and I don't know why it's called B. Background. Let's call it background. B is for the background. I don't know. It's the grid. It prints up an 8x8 grid. But what I'm going to do is add a line that is going to be, because one of the options in this is that, you know, they recommend once you've typed in a program, they give you a couple of suggestions on how to change it. So one of them is how to make the grid bigger. So I'm going to plan for that in advance by adding a variable called G, which I probably should type in the right screen, G, and at the moment it's going to equal 8. So anytime I reference any of the grid size code here, like dimensioning this array or setting up X and Y coordinates where they've got 8s, I'm just going to reference those as G. And then later on we can change it to say G equals 16 or G equals 20, rerun the program, and won't have to make any other changes. So let's dimension our array of G comma G. Alright, we're going to do our first random. So the other thing is about Commodore let. Actually, I believe let does work, but is completely optional, whereas some of the other 8-bit basics, it's not optional. So I'm going to leave that out on here. So we've got n equals int. We're doing the integer of random 1 times g, just in case. So this variable n is the number of icebergs it's going to generate. So it's going to be between 4 and 11 icebergs times g times 8. Do I want to change that 4? It varies from 4 to 11 depending on the value of RND. Oh yeah, that's fine. That's fine. So it means that if we've got a bigger grid, the value, the number of icebergs will grow to suit. Cool. I equals 1 to n. Yep. So now we're going to be going through and setting up where in the array our icebergs are going to be. So let's go 50. So it's what it's doing here is b doesn't equal b. So we're setting a value int in random locations times g plus 1, I believe. Yes. So it's now generating a random grid location and is going to assign a character into that, a text character, and that character is going to be the asterisk, so that when it prints the grid, it'll print the asterisks at the right locations. So we want to generate another random number for the other part of the location, 8 plus 1, because the number might start with 0. Equals, and so we got here, it's 23 on ZX81 and 42 on the other computers is the code for asterisk. Alright, so that is the ASCII or PETSCII code for the asterisk character. Alright. Now another thing I'm going to do, which is on Commodore Basic, the code has got next I, but that is also optional on Commodore Basic. We don't need to we can just say next and it can figure out what you're referring to, even if you have multiple nested loops. So this has a lot of random numbers. So SX, again, badly named variables. This is the enemy ship. So the SX and the SY are the enemy ship excuse me, coordinates. So we're effectively doing a similar thing to what we did with the with setting up the icebergs, except instead of doing it all on one line, this has been broken down into multiple lines, and part of the reason for that is because we want to make sure that there's nothing else already in that grid location first. So for example, if we had set up an iceberg in grid location 3, 4, then we don't want to put the enemy ship on 3,4. Oh, I just realised that in the previous line, on line 50, I put an 8 there where it should have been a G. Flip-a-neck. I will fix that in a second. Where are we? We're on line 70. Random times G plus 1. Close that parenthesis. Alright, so let us change that to a G. SY is going to be int rand1 times G plus 1. Do I have that all correct? Mostly it looks okay. I'm sure you'll let me know if I get it wrong. 90. So now what it's doing is it's saying if B SX SY is not equal to 0, in other words, if there is already something at that location, then go to 70. And again, because it's Commodore Basic, in an if statement, if you do an if then, after the then, you don't need to specify a go to. If it's a go to sub, you need to specify it, but if it's a go to, you don't. This will magically go to. So what it's saying is that if there is already something there, go to 70 and regenerate a new X and Y coordinate until you basically find a coordinate that is not got something in it already. So then what we're going to do is we're probably going to do a line number, and we'll say the background at SXSY location is going to equal, and they've got 63, which is a ZX81 code for a Z, but on every other computer on the planet it is 90. So BSXSY equals 90. Groovy. Okay, now we're going to do the same kind of thing again, but for the player. So the player's coordinates are y, x and yy, which I'm presuming stand for your x and your y. Yep. Instead of retyping these, let us go to, we'll insert a character and go, what are we? We're supposed to be 110. YX. Insert a character 120. YY. Insert a character 130. YX. YY, but we want to jump to 110 this time, and 140 YXYY is going to equal 62 on the spectrum or 89 for everything else. Okay, what have we got so far? Bam. So that, I don't look like I'm missing any lines yet. The line 150, here's another one. Commodore doesn't have a CLS command, so if we go down below, it has suggested we type, see on the triangle, print home character string 147. So we could do that, or we could go print quote shift home, and that would do the exact same thing, and we'll do a semicolon as we don't want to go to another line. 160 for y equals 1 to g. Yeah, because it's now setting up the grid array on the screen. 170. So by this point we've figured out where all the icebergs are, where the enemy ship is, and where the player ship is, and so we're going to generate we're going to print out the grid. So anywhere that isn't populated is going to have a full stop. So we've got for y equals 1 to g, 170 is for x equals 1 to g, 180 if b x comma y equals 0, and 210. Because that means there's nothing there. So it's an empty grid space. Because it's going to skip ahead this. If it's not an empty grid space, then there is something there. So we are going to print the character string. So you remember that we put in these PETSCII ASCII code numbers. We don't want to print the number, we want to print the character representation of that. So we use the CHR string, the character string, and it's going to be of whatever is in x comma y, and semicolon because we don't want to go to a new line. Okay, and then we're going to go to 200. 210, we're going to print a full stop. So this will be the line that gets jumped to if there's nothing at that grid location. So a full stop means it's a space that we will be able to move on to. Put a semicolon, 220 print space, and that is because it basically pads out each column and each row as well. Actually, it does. So each row and each column, it doesn't print everything compressed up in an 8x8 grid. It'll space it out. It'll print one character, space, next character, or grid location, space, next grid location, and so on. That makes sense. 230 next x, we don't need to put that. So 240 is going to be print because we've now gone across the x-axis. So now we're done. We want to print a new line to print the next grid line. And we've done that line. So 260 b yx yy equals 0. This clears your current position from the grid so you can specify a new one. Yeah? Cool. So it has placed you on the grid, and then when it goes into the main, effectively just before it starts the main game loop, it is going to say, okay, well, let's clear that. I don't know why it does the clear. Probably doesn't need to. Because when you move, it's probably just going to reallocate it anyway. So probably unnecessary. Print. So now it is going to ask what direction you want to move in. North, south, east, west. And we'll put a semicolon there. Now I think that it's interesting because a lot of the games in here I think were written because they were written for some computers that were older, such as the VIC-20s and so on, that had they must have had about 20 characters across the screen. So a lot of the output effectively doesn't cross over that 20 character boundary. So that's why I think things like this, they put the input prompt on the next line, whereas we don't need to because we got a whole 40 character width, baby. Oh yeah. Input the D string. So more, what are we doing? Why is there a triangle there? Ah, right. So this is a calculates your new position, checking that you don't go over the grid. So the reason there's a triangle there, you'll notice YY equals YY plus south. And if we go down here, YY equals on the every other computer, YY equals YY minus. And the reason for this is because true and false are flipped on different computers. So for the ZX81, for example, it's got here, computers can decide whether an expression is true or false. If the answer is false, they give it the value 0. If it is true, some computers give the value +1, others -1. The Commodore 64 -1 is true. So these have been written for the computer where +1 is true. So we just have to flip those around. Okay, so we don't need the let, so we're going to go YY equals YY minus D string equals S, and YY does not equal number of grid locations. We're going to get back to this code because this here and these lines here that calculate the enemy's new position are, well, actually especially these ones here, these. So I'll just show you. Now, if we, this is basically doing a couple of Boolean checks, so true-false checks, and it is using the results of those true-false checks to move grid locations, which is kind of clever. So let's just set up D string equals S. Yeah. Now we're going to go print. How do I do it? If D string equals S, I'm not sure how to do it from the command line here directly. Actually, I wonder if I can go print D string equals S. Wonder if that'll work. Nah. I'll show you a bit later on in some of the other code. Okay, what did we get to? We did 290, so let's plow on ahead for a sec. Let's go YY equals YY plus, oops, D string equals north, and YY, not teletype, does not equal 1. So this is basically making sure that we don't move too far across or too far the north, so you can't go higher than grid position 1. And it does that check, and it basically, if you try to, then this Boolean logic is going to result in a 0 or a -1, and it'll bounce you back. So it's kind of clever. So now we're doing yx equals yx minus d string equals east, and yx does not equal the highest grid location. 320 yx equals yx plus d string equals west, and what L does not equal 1. Where are we at so far? Cool. Now there is one gotcha with this program, which is if you press a key that is not one of these, it doesn't do any bounce, it doesn't do any checking, so it will just let you do it. If you press A, it won't move you, but the enemy ship still will move. So that's maybe something if you want to edit the code to do to make that change, but it's a interesting thing to note. So 330, if the background yxyy equals, so we've got 63, so we need to double check 63 for our computer is a 90. If it's 90, then we'll go to 500. So this is checks your new position to see if you've bumped into the enemy ship or an iceberg. So the character 63 up here is the enemy ship, so that's the Z. So this is checking if your player X and Y grid locations equal 90. So in other words, if the character that's inside there at that grid location equals 90, then you're going to have a bad day. And if it equals, if the yxyy equals 23, what was 23? That was 42. If the character that's in there is equal to 42, then you're going to have a different bad day. Okay, so now if you don't have a bad day, it's going to assume that you've moved to a safe position, and it's going to put the character code for your ship inside the new grid location, and then it's going to assign your previous grid location to, is Essex your previous location? I thought that was the enemy ship location. Ah, right, so it clears the enemy ship location because it's going to move. Yeah, I guess that's why they did it there, because they They clear your location where you currently are, and because the loop starts back up here, so that where the clear screen is, each time you move it goes back up to that clear screen. So it'll clear your location, it clears the enemy ship's location, and then sets you and it in a new location. So 350, don't wipe over that line, 350 b yx comma yy equals 62, which is 89 on our computer, and 360 grid location for the enemy ship equals 0, so we clear that. Now this is clever code. This and the reason why I chose this game to start the series with is because this is the fundamental of the enemy AI, and it is brilliantly simple. Plus sign, so this SGN command will tell you if the number is positive or negative, and it will use the result to increase or decrease that location, but it'll be based on whether it is relative to your position. See, we got, so you'll see there it's going to update the SX, or the ship's X coordinate equals the current X coordinate plus sine of YX minus SX. So your X location minus their X location. So that means that it's going to get closer to you. Anywhere you are on the grid, it's going to move one grid location closer to you. And the way that works is, let's say we've got a variable called Z, and it equals 4. So Z, well, let's say that's the enemy ship, right? Because that's the character on the screen. So we've got Y equals 8. So you're at position 8 and it's at position 4. It wants to come closer to you. So to do that, it will want to be on position 5 because that brings it one step closer. Right? So if we print Y, your location, minus its location, we'll get 4. The difference is a positive number. Yeah. So if we had been on location 1 and we print the difference between your location and its location, the difference is a negative number, right? It's -3. So the code uses that. So we want to print the sign of Y minus Z. We don't want to get how many, we don't want to get the exact distance, but we want to say, do you want to move on the x-axis 1 to the left, 1 to the right, or do you want to stay put? So if we were on the same x-axis but a different y location, the difference would be 0, and so that would mean that we don't want to increase or decrease the enemy's x coordinate. So you'll see here we are at location 1 the enemy is at location 4, the sign of our location minus their location is a negative number, so the result is -1. So if that was the case, then the ship's X location will equal the ship's X location -1. So it's going to bring it closer to us. Yeah? If we were back on 8, it's a positive number. So the sign difference will give us a 1. So if we are at a higher grid location than the enemy, its x-axis or its x-coordinate will move 1 higher. It'll add 1 to it. So I'll say its current location, right? So that, let's print that. I'll just add on here plus Z, right? So this is effectively what it's doing. The ship's current coordinate, which in this case is 4, plus or minus 1 or 0 depending on where the player is, and its new location is going to be 5, which brings it 1 step closer to us. I hope that makes sense. I hope I made that clear. So that is the super simple genius AI in the game that makes the ship follow you. Alright, let's clear the screen. Let's look at our listing so far. We've got line 370. So let's do the Y coordinate, which is 380. So the ship Y equals ship Y plus sign of the player Y minus ship Y. Oh, and I should have gone if Z equals 4, Y equals 4. They're both exactly the same, so if we printed the sign of Y minus Z, the result will be 0. So it will stay in the same location, so it won't add. So yeah, hope that makes sense. 390. We're moving on through this. It's taken a while. 390. If the grid location for the ship SXSY is equal to 62. What did we figure out 62 was? Was that 89? Yep, 89 equals 89. 390, if it equals then 500. So it's checking to see if the enemy has hit an iceberg or has caught you. And I just realized that I used the wrong number up on here, because 340 should be 600. Not so 500 and 600. 500 is somebody hit an iceberg. 600 is you hit the enemy ship. 700 is the enemy ship catches you. I think 700, he's hit one. Yeah, no, he hit an iceberg. 400 if BSX SY, we're in the home stretch, equals 23, so there was 42 for the asterisk. Then 700. 410 BSXSY equals 63 is 90. So it's now placing the ship on its new grid location. For 20, go to 150. So that's everything has moved, and if there has been no in-game, i.e. nobody hit an iceberg, or you weren't caught, or anything bad happened, then we go into the next loop. So 500 is the first one you've been caught. So that is what happens when the enemy ship, when it moves into you or you move into it. I don't know why you would move into it. You'd have to have a pretty drunk captain to do that. You've hit an iceberg. You have a bad day. 610, go to 800. 700, print. You're safe. He's hit 1. I think it's a bit sexist to presume that the enemy ship captain is a he. Although maybe in this case it's safe to presume that if they're drunk enough to hit an iceberg, then it probably is a guy. Now, for some reason, these games in this book, they always put stop instead of end. Now, the difference between stop and end is that end will just end the program when it finishes running and it'll go to the ready prompt, whereas stop will actually say break on line number and then which line number it ended on, which is always going to be 800 in this case. But if you've got stops scattered throughout your code, maybe it's useful so you know when it stops. Or maybe some of the other platforms don't have end commands and they just couldn't be bothered putting another clarification for. Anyway, so here's our code so far. We're done. That is the entire game. Amazing. That only took us almost an hour. Let's run it. Do you reckon I made any bugs? Oh, shitballs. What the? What? Didn't even print that. G equals 8. Dimension the array. I wonder if that has anything to do with this shitty run. Oh, there we go. Syntax error. This is one of the things I like about this Lodestar Basic, is that when it hits an error, it takes you to the line and lets you just edit it straight off, which is great. Oh, I think I forgot to put a second close parenthesis. So we got 1, 2, open 1, 2, yep. 1, 2, open 1, 2, and then the outer one's 1 and the other guide. Okay. Something else has gone wrong. Something's gone wrong. Break in 200. Why is there a break in 200? What's wrong with line 200? Go to 220. Wow. Oh, did it go to... I made an infinite loop. Oh, that's bloody clever. You could have at least told me. There we go. Beautiful. So now you can see, hopefully, now that we've typed our program, oops, I'm going to enlarge that. Yeah, look at that. Here we go. Now we don't need the PDF anymore. So we are here. He is there. Odds are we're not going to be able to get to behind that because he can move diagonally. We're screwed in this game. We're going to go west. That's that way. Or that way. That way. Judging by your screen. Oh, that. Oh. But if we go west again, so he's still there. But if we go south, so he's just moved diagonally. Ruh-roh, we've been caught. Z, Y. Oh, great. We can probably just go like north. Yes, he hit one because the code. And that's a good thing about the AI is that it's predictable, right? You know that all it was going to do was say, so we had moved from here to there. So, I can move the camera. We'd moved from here to here, and we knew that the code was going to say, all right, I'm here. I want to move one direction, one position closer on the x-axis and on the y-axis, right? Because we were here, so it's going to say, yep, I need to get closer on both axes. And he hit an iceberg. So that's pretty funny. So we know also if we just go south, he's going to go, yeah, and hit that. Okay. So that's an 8x8 grid. What line are we on? So if we say change that to 12, rerun it, bam, we've now got a bigger grid. We only have 4 icebergs. That doesn't seem like a lot, does it? It is random. So, yeah, but it's very slow, you see. So we know he's going to catch us now because he's going to come diagonally into that space regardless of whether I move or if I move this way, he'll probably go into there as well. So there's no way we can get him because he can move diagonally to crash into one of those. You've been caught. Actually, that's an interesting point. It doesn't update the grid, printing the grid before you get caught. This video's already been an hour, so I don't want to. Let me know in the comments. Do you want a part 2 where we update this and try and make it so that, when a collision happens, it gets drawn up before we get caught or before we hit an iceberg? That'd be pretty easy to do. Something that might be a little bit more complicated would be getting the drawing to speed up. We might be able to achieve that by doing, if we do prints and do like down, 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 right, and figure out where if I print that, so I'm gonna print and move. But if to do that, we would have to do a loop to say, kind of start the printing from the home location and then figure out, okay, you're at locations 5,4, so we're going to have to do a loop, another 4 x equals 1 to whatever and y equals 1 to whatever, and then go do a loop that each time we go through the loop it prints another down and each time it goes through the while loop it prints another across. So that might end up actually being a lot slower. Let me know your thoughts. How do you think we can improve the writing, the displaying of the screen to speed that up? I'll leave a link below to where you can download the book from. And let me know what you think. I would like to keep doing more of these. And we do have more. We've got the wall and missile. Missile is definitely a graphic program, which is why there is a completely separate listing for every single architecture. And the wall, I don't know what that is, but I'm going to maybe guess it's that program there. That one there is probably missile. So, yeah, thanks for watching. And leave your thoughts and comments below. What would you like to see next? Do you want to see another video, another listing in the series next? Do you want me to try and update the code next? Both? Either or? Thanks, and I'll see you in the next video.